Hi everyone, in this video we're going to go through 11i, the area between two curves. So just to let you know, this is the second video I've created and I pretty much got to the end or near the end when on my little timer said time's up, you've reached the maximum for this video, and I was like, whoa, like the maximum time is like well over an hour and I had not even spoken for probably 20 minutes. So upon investigating, it had sped up the timer and it also just recorded white noise. So instead of hearing my dulcet tones, when I was listening back, it was just shh, white noise, which was really, really annoying. And I'm sorry, that was probably really, really annoying in your ear. So I don't really want to go and write it all again. And it was such a good video. I feel like it was one of my better ones. But anyway, I'm going to talk about it with the writing already there and just point to what I'm talking to. Okay, so what we're going to be doing in this video is looking at the area between two curves. So you can see I've got a little bit of highlighting done here. So I highlighted this definite integral. So we're going from a to b and we're taking the antiderivative of f of x. So if we're looking at that area, and I redrew this awesome graph, this is this area here between the curve and the x-axis. So the curve f of x and the x-axis. Now, if we want to find the area between two curves, which is this area here, all right, so think about, well, it's basically that yellow area minus this green area. All right, so that's why I've highlighted that in green. So if we want to find the area of something, we find the area of the larger thing, the area of the larger space, so that is the area between the curve f of x and the x-axis, and we subtract the section we don't want. So we don't want that green section. So you can see over here, what I've got is the area that I shaded in yellow minus the area that I've shaded in green, because that's the area we don't want. And then we're left with the pink area, which I've just put a little square around the formula for that. All right, so we're still working with definite integrals, but basically we're looking at the area between two curves, and you've got to subtract your lower curve, so in this case g of x, from your, I chose yellow, guys, come on, from the curve that is on top. So it's the top curve minus the bottom curve. So when you're doing questions like this, you need to find mostly two things. First of all, you need to find the point of intersection, so POI, the point of intersection of the two curves, or the two functions, whatever you want to call it. And then the second one, you need to work out which function or graph is on top. Now, obviously, if you did it the other way around, you're going to get a negative area because you're going to be taking a small area and subtracting from that a larger area. So you're going to have a negative answer. But it's probably going to save time by just doing a quick check, and I'll explain that in the video as well. So once you've found the point of intersection of both curves, so basically that gives you A and B. So x equals A and x equals B, your 2 points of intersection, and that's going to be on your definite integral. And which function is on top? You choose a value, choose an x value, can't write, might just turn that s into an n, x value between those two. All right, so something in between. Now, if 0 falls between them, easy peasy. All right, the best one to do, or 1. Okay, but if you had to choose a number, I don't know, between 5 and 10, yeah, you're going to have a little bit more of a challenge on your hand, but it's okay. still manageable. All right, so that's what we're going to look at. So in these three questions, And I did question 1 and 2 before I realized that the video was not working. You got to do those 2 steps before you do anything with your definite integral. So we've got to find the point of intersection of the 2 curves and then decide which function is on top. All right, so here is our working out. Let me just make it a little bit bigger. Now, if you want to pause it and write it all down or just wait until I've talked about it. All right, and where's my little thing? I'll just get rid of this because I don't know why I circled it. And I'm going to highlight things in in yellow. All right, I did graph it. Let me just get rid of all these. Are these circles going to go? No. All right, I did graph the 2 functions. So you can see it's a parabola. So the first one was a parabola, and then you've got a linear graph. So all those little circles. So let me just do it in a different color here. This one here and this one here are our point of intersection of the 2 graphs. Okay, so you can see that's where the 2 graphs intersect. So that's my first bit of working out here. Let me just get my yellow highlighter back. All right, so we've got our first equation, 12 minus x squared is equal to our second equation, x plus 4. All right, because y equals and y equals means, you know, the right-hand side of both equations are equal to each other. And then we're just got to bring all the like terms together, and then we're left with a parabola. Now, you're just solving that. You're factorizing if you can, just working out 2 numbers when multiplied give you -8 and add to give you 4. Now, if it's not a straightforward one, then you use the quadratic formula, or you can complete the square. But, you know, the purpose of these is not really doing a complex factorization or a solving. It is actually finding the area. So I don't think any are really that difficult in terms of factorizing or solving a quadratic. Okay, so we've got these 2 solutions, x equals -4 and x equals 2. Now, because you're used to finding the x-intercepts that way, just be careful not to get confused and think, oh, they're my x-intercepts, and then you draw your parabola with those x-intercepts, because they're not the x-intercepts of your parabola. They're the points of intersection for your parabola and your straight line. All right, so we've done that, and I've highlighted them in pink for you to see. All right, and then the next step is to check which graph is on top. So with our definite integral, it's now from -4 to 2. So you just need to find a point in between those 2 values. And it can be anything. It can be -3, it can be -1.875, which would be a really silly thing to do, but you choose the easiest one. And the easiest is x equals 0. So when we substitute x equals 0 into our parabola, we get y equals 12. And when we substitute it into our linear graph, we get y equals 4. So on our graph, and I'll highlight that in green, there's y equals 12 and there's y equals 4. So even though I graphed it and we can see our parabola is on top, just doing this little check here, if we didn't graph it, just tells us which one is on the top and which one is on the bottom. And that's really important because your top one goes first, which is here, your parabola, and then we're subtracting the second one. And you'll notice I did a little bit of working here. So let me just change that. So it's an x plus 4. So if you're subtracting something that has multiple terms in it, put brackets around it because you don't want to just assume that it's that, which is completely different. So you're multiplying the x by negative and you're multiplying the 4 by a negative. So I'm just going to now change that back to a negative. You can, if you feel like you might get a little bit confused, you can obviously set up 2 definite integrals. So you can do one for find the area of the parabola and then find the area under the linear graph and then do your subtraction. Okay, so that's completely fine to do them separately. And we all know that bringing everything together like I did last lesson and I got the wrong answer probably shows why it might be good to, separate things. All right, so when we do that, bring everything together, we actually get this nice little definite integral, which I've noticed I forgot to put dx on the end. So when we're finding the antiderivative of that, you can see I've put that in the square brackets and then put the a and b values on there as well. All right, so just turning to the next page, there's all my working out. Now I've done a few highlights there, so I might just get rid of them. It's going to let me. Oh, it doesn't like highlighting. I had to save this document and reset my computer. All right, so you'll notice I've got substituted in 2, and I think it's a good idea to put any number you're substituting in brackets. So you can see here, everywhere, oops, I didn't do it there, but everywhere that was an x, I've put a 2. And then we're subtracting the substitution, the same antiderivative, but this time we're substituting in -4. Now, if you've got a negative number, extremely important to use brackets. So I like a lot of brackets just to try to not get confused with the negatives. All right, so just be careful with that. All right, so then I've expanded it. You can see this negative here. So -4 squared is 16, but that negative is outside of that squared, so we do need to have a -16. Then I've highlighted our 2 fractions. So we've got an improper fraction here, and I showed you this in class that instead of leaving it as an improper fraction and writing everything else as a fraction over 3, which is very time consuming, just separate that improper fraction to mixed numbers. So -8 on 3 is the same as -2 minus 2/3. And then 64 on -64 on 3 is the same as -21 minus 1/3. And that's a lot easier to deal with. So you bring all your integers together and you'll get 37. And then your 2 fractions, so -2/3 minus 1/3 gives you -3 on 3, 3/3, which is 1. And there's our answer, 36. And in the previous video, I did check it on the calculator and it is 36, which is pretty awesome. All right, so I'm sorry that I'm not redoing this video just because I'd already done all that working and it was all really, really neat and great and not too messy. So let's move on to the second question. And did I finish? Oh no, I didn't finish this one off. All right, so in question 2, we've got 2 parabolas. So we've got 5 minus x squared and we've got x minus 1 squared. So the first step, finding your points of intersection. So I've gone ahead and done that. This highlighting here was just showing that this is a negative and this is a positive. So don't go out and cancel out those x squared, because obviously when you bring the x squared over, it becomes 2x squared. And then simplifying by taking 2 out as a common factor, you're left with x squared minus x minus 2 equals 0. So then we get our 2 points of intersection, which I did right up the top. Yeah. All right, x equals 2 and x equals 1, -1, sorry. Now I know which one is on top based on my knowledge of parabolas. So this first one is actually a negative parabola that's been shifted up 5, and this other parabola is a positive parabola that's basically sitting on the x-axis. Okay, so I know this one is on top, but if you didn't, you could just substitute 0 in, and if we did f of 0, you would get 5, and if we did g of 0, we would get -1 squared, which is 1. All right, so you can see f of 0. It's not hard to do that check. All right, so f of x minus g of x, I've just put them in, and then you've got, I've actually written the actual functions in. So you can see I've got brackets here just so we remember to subtract the whole thing. So I'm going to set that up for you. So -1 to 2, 5 minus x squared. That negative applies to everything. So we're going to have minus x squared. Negative times the -2x, so plus 2x, and then minus 1. And don't forget the dx on the end. All right, so bringing like terms together. We've got 5 minus 1, which is 4. Then we've got -2x squared plus 2x dx. All right, so go ahead and do your definite integral, and then you can check your answer on the calculator. I just want to do one more from the beginning, so I'm going to choose another one here. Why did I make this bigger from the beginning? I'm very sorry. Actually, I did. I think I just, and I'm sitting here in the dark on a Saturday night waiting for my son's basketball game. All right, so what do we got? 3, well, we've got parabola. Might do C, because I always did make the last one the easier, the hardest. So we've got y equals 3 minus x squared and y equals 2x squared. So I can already see which one is going to be on the top and which one's on the bottom. Okay. Where did I even write that question? I've got a piece of paper next to me where I write all my notes. And I just have random stuff written there and I can't decipher where it is. Okay, y equals 2x squared. All right, so we want to find, first of all, the points of intersection. Now, if you're doing this on your calculator, just make them equal. Solve, let them equal each other, or you could graph them. But I'm going to assume that we have to do it by hand. 2x squared. All right, so we're going to have 3x squared minus 3 equals 0. Just double check that because sometimes we can do things quickly. All right, and then we take out 3 as a common factor. And then we've got x squared minus 1. So we can do the difference of perfect squares. So it's going to be x plus 1, x minus 1 equals 0. So x equals -1, x equals 1. All right, so before I did say I knew which one was on top and which one was on the bottom, but let's just say we didn't know. So we worked out that our points of intersection are -1 and 1. So we need to choose a number in between those two, and it's just great that x equals 0 is in between. So when x equals 0, your first solution is y equals 3. So that's the intercept of, the y-intercept for the first parabola. And then for the second one, so I'm going to do y2 is 0. Okay, so you clearly now see that the second parabola is on the bottom. So we're going from -1 to 1. Put your first function in, and then we're going to subtract 2x squared. I don't need to put brackets in simply because there's only one term there, and I'm not going to get confused or anything. All right, -1 to 1. Oops, why am I writing that again? I can actually find the definite integral now. -1 to 1. All right, so 3 becomes 3x. Oops, it should be x cubed. Now you could put this in order of powers if you wanted to, but no, I'm not going to. Minus 2x. Oh, what did I do there? Did I not bring the light? Oh gosh. Sorry guys. What did I do? Did I do anything wrong? No. I just didn't bring. There we go. I'm rushing and I didn't bring my like terms together. So it's 3 minus 3x squared dx. All right. Oh, actually, what I might do. Get rid of all that. Sorry, guys. All right. You can take out the 3 as a common factor. And then we're left with 1 minus x squared dx. And that might make things a little bit easier. So when we're doing our definite integral, you can just take that 3 out, the front of those brackets. So 1 becomes x, and then minus x cubed on 3, -1 to 1. All right, so we've got 1 minus 1/3. I need to put bigger brackets out. And then, so that's the first substitution, and then minus -1 minus -1/3. So clearly that would be a plus, but I just put it there so we could see it. All right, so 1 minus 1/3 is 2/3. So this becomes a plus. 1 plus 1/3 is minus 2/3, and then another minus makes it a plus. All right, so that 3 is going to cancel 4/3, so it's just going to be 4. All right, so what I did, sorry, I probably did that a bit quickly. Okay, so that 3 is multiplying both these terms. So you could have done 3 times 4/3, and then they cancel out and you're left with 4 as well. All right, let's check on the calculator. All right, so just making sure everything is correct. So I'm just going to do it from the starting one, this one here. Okay, so it's a bit hard, I'm not giving you much. Okay, so keyboard, so we want our definite integral, where are you? So we're going from -1 to 1, and then we've got 3 minus x squared minus 2x squared. So I'll just put them both in there, dx, right, and it's equal to 4. So just re-emphasizing, you've got to find the points of intersection, then decide which one's on top and which one's on the bottom, and it's not always going to be as straightforward as these ones are. And then you're just doing your definite integral. Okay. All right, just wanted to do a quick check to make sure there was no other questions in your notes, which there aren't, other than those other questions from question 3. But do make sure you have a go at some other questions in your textbook. Just don't assume, oh yeah, that's all right, I'll remember that. You really need to practice it. All right, bye.